everyone. So, today I am going to discuss about a particular course which is on natural extract as a replacement to synthetic chemicals in textile finishing. So, in this particular course what actually I am going to cover, broadly I am going to cover three things in three different modules. In the first module I am going to cover the introduction and what are the opportunities and challenges of using natural extract or natural biomolecules on the textile substrate for value addition. And this particular module, that is introductory part and the opportunities and challenges, that actually I am going to cover in today's class. In the next module, I will just take up the different functional properties of natural extracts to have antibacterial properties, to develop antibacterial functionality using different kind of biomolecules. That actually I am going to cover in the next module. And the third module, I just extend my discussion the natural extract is its properties on fire retardant property on textile substrates. So, the moment we talk about textile finishing, so basically the highest value addition which is going to happen in textile chemical processing side, so that is the finishing segment, right. So, this finishing means to give different kind of functional property to add values, and this functional property can be developed on textile material by two different ways that we all know. One is the physical treatment process and another one is the chemical treatment process, right. So, in physical treatment process, for example, apart from calendering or different kind of heat treatment, the most of the innovations or functional property development comes under the category of the chemical treatment process, right. And this particular area, using some chemicals, different kind of functional properties on textile material to have different kind of product which have wide range of application, not only apparel, but the application can be on technical textiles as well, right. So, most of the innovations R&D is happening in this particular area of textile chemical processing using chemical treatment. So, here actually I listed few examples what kind of value addition we can create on textile materials. For example, we can have antibacterial properties on textile material, we can have flame retardancy or flame retardant property on textile materials, then we can have UV protective property, then self cleaning property can also be achieved by using different kind of chemicals on textile material. We can make the textile material waterproof and repellent, we can have durable press finishing on textile material, and then other kind of advanced finishing treatment is also happening nowadays. For example, using phase change material, thermal regulation of the textile material, and we can also have different kind of properties, surface properties. For example, if you want to make the textile hydrophilic or if we want to make the textile hydrophobic, so we can have plasma treatment. So, there are different category of the plasma treatment people are talking about, for example, atmospheric pressure plasma, vacuum plasma, etc. And the last things, lot of things are also happening in e-textiles, electronic textiles, for different kinds of wearables. For example, wearable sensors, then for monitoring different kind of human activities, or maybe some kind of textile which can also harvest energy or can store some kind of energy. So, to achieve this range of functional properties I mentioned over here, not only chemicals, but nowadays different kind of natural extracts can also be explored and a very broad topic of research. For adding this value to the textile material, we are using different kind of chemicals, for example, dye stuffs, and during dyeing we are using different kind of other auxiliary chemicals, for example, salt, then wetting agent, alkali, acids, and the finishing treatment we are using dimethyl dihydroxyethylene urea, citric acid, sometimes we are using butane tetracarboxylic acid, different kind of chemicals like softener, we can also use wetting agent, metal oxide, silicon, halogen, and other kind of stuffs. But range of chemicals are giving various functional properties, that is true, but at the same times these particular chemicals are doing lot of pollution in the environment. So, it is basically is enormous impact, negative impacts on the aquatic life, aquatic animals. So, this is basically a real challenge for the textile industries, especially if we talk about the textile chemical processing industry. So, they have huge challenge in front, how this particular negative effect can be minimized, so that we can have those kind of functional property, at the same time we can minimize the environmental bad impacts. And huge amount of R&D and time and energy people are spending, especially if you talk about the textile industry on reducing water consumption. So, that is one of the area people are tremendously working, and different kind of research people are doing, and how to save energy. So, energy conservation in terms of different kind of electrical energy and other energy, at the same time the water saving is also a big topic of research, right. So, in this particular module actually I am not going to talk about water conservation or different kind of other energy savings, but mostly we are going to talk about how we can minimize the use of conventional chemicals to value add textile material. So, that is basically the real sustainable textile materials once we talk about. So, people are thinking about from the fiber production itself, how the cotton fiber is going to grow in the agricultural land, what kind of chemicals people have used for that, then for after treatment or different kind of chemical processing, for example dyeing and finishing, what kind of chemicals they have used, how toxic those chemicals are, what kind of technology they have used, how sustainable those technologies are. So, those kind of questions really coming. So, in this particular module I will be just talking about the small part of this sustainability, that is the minimization of the chemicals, as I talk how we can use different kind of natural extract in value added textiles. So, this is not surprising to know that textile chemical processing industry, especially they are using a lot of chemicals. If we talk about the worldwide consumption of various chemicals, 25% chemicals directly or indirectly are going to the textile industry, right. And mostly if you talk about the synthetic textiles, so 110 to 820 gram per kg chemicals people are using, and for cotton textiles, especially the natural textiles, the amount is much more, 350 to 1.5 kg per kg of fiber processing. So, a very huge amount of chemicals people are using currently to have the final product what actually we are using nowadays. And because of this is increasing the lot of load in the environment and creating lot of pollution. So, this is basically the right term, or this is topic is really a right time approach how to minimize these carbon footprints by utilizing some other kind of natural extracts which will not create that kind of pollution in the environment. So, in the current days, if we talk about the value added textiles, the lot of many wastage materials, different kind of natural stuffs, few of them may be in the commercial level and many of them are in the research stage. Here actually I have taken few examples, different kind of natural extracts, for example plant parts you can use, the different kind of biomolecules from seeds, fruits, flowers, bark, stems. We can have the animal body parts that can also be used for value addition in textile. Then we can have protein and vitamins, because all the natural materials, for starting from the fruits, then vegetables, then leaves, then stems of a particular plant, animals, those are very rich in different kind of minerals or sometimes tannin kind of material, sometimes polyphenolics, and those compounds has really various functional properties which can be really explored on the textile material. So, if we talk about can you use a fruit material or can you use a vegetable material for textile value addition. So, those kind of stuff people have studied for research purpose, but those are really not feasible in practical point of view, because using a fruit material or using a vegetable material into textile for value addition of textiles is not really, the people are not going to accept those things. So, instead of thinking those lines, people are also thinking about, can you use wastage material rather than the normal food material or vegetable material. So, there are many wastage material which are very rich in different kind of biomolecules, which are very active against different kind of hazards, can be utilized into textile value addition. But the challenge of this wastage material is basically, for example, we are using orange or we are using orange peel. So, the orange which is grown in South India and the orange which is grown in the East India have different kind of varieties. So, there is a challenge that what kind of ingredients or real biomolecules they are really present in that orange peels. So, standardization or the extraction process or for the scale up process is really a difficult task using this particular natural wastage material for the textile value addition, but still there is a lot of promise in this particular area. So, this is very common that what are the advantages of natural extract once we are going to apply in the textile materials. It is really eco friendly approach definitely, and the products are screen friendly, it is also non allergic, and of course, it is non toxic to human, and is sometimes it gives natural color, right. So, there are plenty of different kind of advantage we are getting over here using natural products, which is not there in case of normal chemicals what we are regularly we are using in the textile industry. So, I will just put up some few examples that what kind of chemistry we can use, we can think about for the textile value addition. Here actually we talk about the phenolic and polyphenol material. Actually, the polyphenolic material, for example, catechol or caffeine acids is very much antibacterial in nature, and this kind of chemicals mostly present in different kind of plant material, right. So, it basically interact with the bacterial cell surface and stop the protein part to replicate and stop further growth of the bacteria. So, this kind of biomolecules, which is as I talked about phenolic and polyphenolic material, can be very useful for making antibacterial textiles. So, we need to find out what wastage materials which contain this kind of polyphenolic material which can be really used for textile value addition. Then also we have compound like quinones. Quinine is very useful material which was first discovered to fight malaria, and we can also believe that the first synthetic dye which is commercially successful, that was discovered by Sir William Henry Perkin. He actually tried to develop quinines to destroy the malaria or the parasites, but actually he discovers a particular dye, accidental discovered. The same kind of quinine can be used for different kind of functional finishing, right. And this particular compound has a capability to generate free radical which can make a complex with the amino acids in the protein which is generally present in the bacteria and which can destroy the cell of the bacteria. And this mechanism we can use to, as I mentioned, to develop different kind of medical textile products, underwears, where there is a real requirements of the skin friendly agent, because these particular products is really in touch with the skin. Sometimes this is also should be noted that the natural extract, all natural extracts or all compounds are not really toxicity free. So, that analysis part also you have to do before commercialization of this kind of natural products into in the industrial scale. Okay. So, another compound which is very important, and we can also explore this kind of compound on textile substrates are called flavon or flavonoids or flavonols. I think flavon compounds is very known things to especially the textile chemist, because this kind of flavon compounds are present in natural cotton, and this basically gives a natural color to the cotton fiber. During bleaching operation, generally we target this particular stuff for flavon or this kind of catechin molecules to remove, so that we can get the pure white color substrate or fabric. But these flavon compounds are naturally given in the cotton fiber by the god to protect them against bacteria. So, during their life cycle they are actually not affected by different kind of microorganisms, but nobody thinks about that flavone compound has also beautiful antibacterial property or other kind of functional property. So, that can also be explored. So, as I mentioned, the moment we talk about natural extract, so natural extract, even if it is from the fruit or vegetables, that is more not sustainable. So, is there any technology that flavone compounds can be recovered from the bleaching liquor and that can be used to prepare antibacterial textiles? So, that is really possible, actually you need to think around that line. And similarly, polyphenols, we can, a different kind of wastage material we can use, we can segregate that polyphenols and we can think about the utilization of those material on the textile substrates. Tannin, tannin is another major compounds present in plant material, and there are two forms of the tannin, one is hydrolyzable tannin, another one is the condensed tannin, and this particular tannin compound has some particular color as well. So, it can give natural color in the textile material. At the same time, this tannin compounds has beautiful fire retardant property. So, many researchers have tried to develop fire retardant textiles using different kind of tannin compound, and of course, we are also doing this some kind of research in IIT Delhi using tannin based material on textile fabrics to develop fire retardant textiles, and we are very successful in developing fire retardant textile using tannin based material. The other stuff which is very important is the essential oils. So, essential oils basically is a kind of compound which has very numerous properties. For example, essential oils we can use for aroma textiles, or essential oils can be used for insect repellents, because nowadays especially in India there is a lot of mosquitoes, and these mosquitoes are very much dangerous for different kind of diseases. For example, nowadays the real threat is the dengue, right, and the different industries they are using different kind of essential oils and they are preparing patch, different kind of patch, and these oils actually evaporate out and it repel the different kind of insects, for example mosquitoes and all. But textile industry can also think about, or the researcher can also think about, can you use these essential oils for preparation of mosquito repellent fabric. For example, citronella oil people are using for different kind of patch on the fabric kind of stuff. But can you integrate or can you use this particular essential oils in the textile substrate permanently, which is going to be durable finishing kind of stuff, and you will give long time effect for mosquito repellency property or different kind of other insects property. So, essential oils or terpenoids are one of the major components which can be get from the plant material, and really this kind of oils are very useful. And some of the commercial trial has been taken not on textiles but other kind of stuff, but this kind of technology can also be commercially tried in textile industry. Now, I will be talking about the major challenges, what are the challenges exist using biomolecules for textile finishing. It is very easy that if we want to develop fire retardant textile, for example. So, there are some certain chemicals which is commercially developed and very successful chemical, for example pyruvatic CP, right, and many industries are using this pyruvatic CP for developing fire retardant textiles. But integration of the fire retardant use some cross linking agent. So, we are using some kind of cross linking agent DMDHEU, which generally release formaldehyde later on, right. So, that particular process, although we are giving some kind of beautiful property to textile material which is fire retardancy, but that property is not very sustainable. But this particular chemical is very stable chemicals, known chemicals, and give certain properties. But the moment we talk about biomolecules basically is generally extracted from the plant or animals. Then during extraction process it will give varieties of plenty of different kind of biomolecules, and that plenty of different kind of biomolecules have different kind of properties, different kind of activities. Some of them are very useful maybe, and some of them may not be, right. So, the real challenge exists that whatever extraction process we are going to target, those particular extraction process is giving the right chemical or right molecules actually you are going to target. For example, extraction can be ethanol based extraction process, or the extraction process can be aquatic, for example, water based extraction process. So, we need to think about that the moment we are using water media for the extraction process, so those water soluble biomolecules going to come out only, right. But the moment we talk about solvent extraction, propanol for example, then only that biomolecules which are soluble in propanol, that is going to come out. So, this is actually real challenge, the extraction process, how the researcher or the scientific committee is going to use the different kind of extraction process, whether it is water media, whether it is solvent media, and accordingly we will be able to extract the biomolecules. So, the first of all actually we need to optimize those extraction process where actually we are getting the right molecules which is effective for developing a certain property on textile material. So, that we need to think about. The second thing is basically the moment we talk about the plant material especially or different kind of agricultural things. So, there is a lot of variation of the species from the same family. For example, as I mentioned geographical location, some of the crops which is going to grow in the South India and which is going to grow in the North India will have different kind of varieties, and accordingly their biomolecules component or biomolecules, their constituents may also vary. Once a particular trees is going to become more and more aged, so their constitution may get changed. As I mentioned, extraction process also varies the extraction of different kind of biomolecules. So, that is the real challenge still exists, we need to optimize. Then the second challenge is the integration mechanism is very important task to we need to think about, because the moment we are synthesizing one particular chemical, so actually we know how this chemical has been developed and why this particular chemical has been developed, what kind of functional groups are present in the particular chemicals. So, that is pretty sure or pretty known to us, and accordingly we can design our experiment for the integration or attachment of that particular chemicals to the cotton fiber. For example, cotton fiber has OH group, primary hydroxyl group, secondary hydroxyl group. So, accordingly you can design some chemicals which can have some interaction, methyl group for example, CH2S group which can make an interaction with the cotton fiber, which can make a permanent linkage like reactive dye, and which is going to give a long time value to the textile material. So, that kind of stuff is very easy once we talk about synthetic chemicals, because the synthetic chemicals are known chemicals. But the moment we talk about the natural extracts, unless until we are not going to segregate those chemicals, what chemicals actually we are going to get. So, unless until we do not have detailed analysis on this particular compounds, we cannot predict, we cannot use a particular cross linking agent or what kind of interaction is going to happen, that is not is clear to us. So, integration of this natural extract as it is very difficult, because there is a hundreds of biomolecules and we do not know what kind of biomolecules is going to be attached and which is not. So, as I mentioned, we need to first optimize a process, or we need to segregate the different kind of biomolecules which are really useful to us and actually discard those biomolecules which is not useful to us. So, integration mechanism is still a challenge, because most of the biomolecules are not known to the textile researcher. So, we need to really take help of different kind of additional characterization techniques. For example, we can have GCMS, gas chromatography mass spectroscopy, to really analyze the structure, the chemistry of the particular biomolecule, and accordingly you can design the experiments for integration on the textile material, so that it will give vast durability. Otherwise, this particular biomolecules is very beautiful biomolecules and giving beautiful properties, but the moment we go for the wash, single wash, the most of the properties generally gone. So, that is the challenge still exists, we need to think about that line. And the last challenge what actually just I wanted to mention is basically the high add-on percentage which is required for getting the functional property from natural extracts. For example, sometimes we need to apply 20%, sometimes we need to apply 30% add-on or 40% add-on to have some particular properties. For example, fire retardant property I talked about using tannin material or using some other kind of natural extracts, it requires 20%, 30%, sometimes 40% add-on, which is undesirable thing, because the moment actually we are talking about the 20% or 30% add-on on the textile material. So, we are getting the properties of course, but at the same time we are losing many other properties, for example, physical properties, flexibility, then their look, sometimes it goes down. So, we need to think about that line, right. So, this particular problem can be solved, as I mentioned, low add-on. So, how to actually we can achieve low add-on, still we will give some get some kind of properties. So, the one approach can be a combination of different kind of biomolecules. Combination means we can have two different kind of molecules which will give synergistic activity of the particular properties. For example, we talk about the antibacterial property. So, maybe one kind of compounds can give antibacterial properties, but add-on requirement is very very high. But if we sometimes mix two molecules together, it will give different kind of synergistic activity. So, combination can be one approach which we can be looked into. Nanotechnology is one of the, I think, new thing we can think about. Nanotechnology is very very famous for the metal oxide. For example, the textile substrates, people are using silver nanoparticles, people are using copper nanoparticles and other kind of zinc oxide nanoparticles. So, those are very famous chemicals nowadays, but at the same time silver nanoparticles up to a certain level it is okay, but beyond that it also very very toxic. For example, if we talk about the filter fabric, for example, water filter, many people have tried to use silver nanoparticles, but at the same time silver nanoparticle going to leach out in the water media, and that is very very unhealthy. But nanotechnology can also be used for the different kind of biomolecules. The thing is that whatever biomolecules we are getting over here, and as I mentioned, it requires high add-on on the textile substrate to get the functional properties, but can we convert those biomolecules into different kind of nanostructure, for example, nanoparticles, right. So, just I will be talking about a few examples of nanoparticles of the biomolecules where actually the properties or functionality is going to enhance like anything, right. So, instead of using the 20% or 30% add-on, if you convert these biomolecules into nanoparticle form, then maybe 50% add-on, for example 50% of the 20 means 10% add-on, or maybe 7% add-on, or maybe below sometimes 5% add-on may be quite good enough to have the property, right. So, nanotechnology is basically can be a focus area to convert different kind of biomolecules into nanoparticles and to enhance the property where add-on percentage can be low. The third one is active ingredients. We can I just already mentioned the active ingredients means we need to only focus those biomolecules which are active against the particular hazards. For example, fire retardancy or antibacterial property. So, here actually we are not going to target other biomolecules. There are hundreds of biomolecules which are present in a natural extract, right. But for neem extract are hundreds of compounds, bioactive agents, but only 2-3 component which is called nimbin or nimbidine or azadirachtin is basically are responsible for different kind of antibacterial properties or mosquito repellent property kind of stuff. So, we need to segregate those unique material or unique biomolecule from the whole extraction process, and we need to integrate those active ingredients only to the textile material, and in that way actually we will be able to achieve property using low add-on. And the last thing is the main one of the major issues of the natural extract, the researchers knows that it is very difficult to have durable finishing from natural extracts, because the same thing, once I am repeating the same thing over here, wash durability absolutely depends on the what kind of chemical linkage or what kind of chemical interaction or what kind of chemistry is there between the textile fiber and the natural agents, right. So, here also we can use different kind of cross linking agent which generally being used for the synthetic chemical. For the synthetic chemicals we use different kind of bridging material, for example, formaldehyde or other kind of citric acids or butane tetracarboxylic acid or sometimes glutaraldehyde kind of stuffs. But here actually the moment we think about the sustainable approach or using natural extract, we cannot think about the cross linking agent like DMDHEU, which generally release formaldehyde. So, by studying the chemistry of the natural molecules, by studying the chemistry of the textile fiber, what kind of textile fiber we are going to target, accordingly we need to select a cross linking agent which is also not very toxic. For example, glycol glyoxal combination can be an options, which is basically toxicity free, or can be citric acid. Citric acid basically is nothing, is very safe material, citric acid. So, use of cross linking agent, proper cross linking agent can enhance the durability of the natural finishing we just talked about. But again a lot of research is required in this particular line, because up to now we are not clear what kind of molecules actually is going to be attached on the textile material. So, just conclude this particular module, I just want to convey these things that natural extract, different kind of natural extract, whether it is plant based or whether it is animal based, is very promising, very effective for controlling the pollution which is going to create by the synthetic chemicals. But at the same time there are a lot of research required for optimization or extraction of the biomolecules, their chemistry study, their interaction parameter, how they are going to be part of this textile material. So, there is a huge gap still exists. So, you need to work on that particular line, and I think sometimes this particular natural extract is going to be very successful commercially in the textile industry, because the research started for chitosan. For example, chitosan basically we get from aquatic animals, and very low amount of chitosan generally you can extract from the aquatic animals, and that 10-15 years before people did not think that this particular material is going to be commercialized. So, those time people only use those material for the research purpose, but nowadays we can see that chitosan material has different kind of commercial trial. Different kind of commercial trial means it is including the textile industry, it has cosmetic industry people are using, biomedical industry people are using. So, my take from this particular module, what actually I am going to give a message this, that this particular area is very active area in the research wise, but still now we need to do many things to make this particular area commercially successful. Thank you.